This little light of mine. I'm gonna let it shine, let it shine, let it shine, let it shine. This little light of mine, I'm gonna let it shine. This little light of mine, this little light of mine, I'm gonna let it shine. I'm gonna let it, this little light of mine, I'm gonna let it shine. I'm gonna let it shine. I'm gonna let it die into flames.
Okay, guys, that's enough. The light we're going to talk about is the light coming from the sun, but reflected off the moon. Yes, you didn't know you were getting recorded out of this, did you?
I figured it was happening.
Well, anyway, let's talk about the moon.
Oh
The moon. I can't
we're
talk.
We're going to have to redo this, aren't
No,
we?
we're not.
Are you
The
sure?
moon.
I think we're going to have to redo
I think
this.
so. Probably be our biggest hit. As you can see, the moon is roughly 240,000 miles away from the Earth.
I got sunshine on a cloudy day.
For an astronaut, it takes 2 or 3 days to get there, and they had space capsules like this. And I'll try to get through this. But anyway, the astronauts would be way up at the top right here. Okay, fine, I'll stop it. I lied, it's still going. The astronauts were right up here at the very top.
Come on, gotta do something live. Yeah, man.
Well, anyway, the astronauts were right up here at the very top.
Walking on the
Giant steps are what you take, walking on the moon. And when the astronauts did, they were up at the very top of this rocket capsule here, and it took 2 to 3 days for them to get the 240,000 miles. If you were to be able to take a jet plane, which you cannot, of course, but if you were to be able to take a jet plane, it would take 20 days in which to get there, which is not near as far as it is to any other planets. The moon is relatively close to the Earth. Something kind of interesting about the moons, and most moons in our solar system.
They're made of cheese.
No, they're not made of cheese. But anyway, the moon here, you can see by these arrows that it is always facing the same side toward the Earth. So that means the moon turns one time around on its axis each time the Earth turns one time around. So we really only see one side of the moon, no matter what the moon phase, no matter what time of year, no matter what time of night that we happen to see the moon, or day, and you know it comes out a little bit of the day. That's kind of interesting. It's not just the moon that does that, not just our moon that does that. Some other moons do that as well. Anyway, the moon has dark features and light features. I'm sure you may have noticed that, but you see the dark features here, the light features there. And you can see what they're called. The dark features, it looks like it'd be called the mare, but this is not horses here. This is called the mare. Now, mare has a plural form called Maria, which is M-A-R-I-A.
No.
Not Mario. The Maria. And in fact, I might want to kind of jot it up here in case you happen to think Mario. It's not Mario, it is Maria. You guys are having fun with this. But anyway, the mare is the lowlands, and the highlands is right here in the lighter area. Lowlands are dark, highlands are light. Now, this is not, well, whenever the side that we see all the time is called the near side. But the other side of the moon, the far side of the moon, we've got a telescope out there in which to take good pictures of that, and it doesn't have near as much mare as the near side does. Now, I'm going to need to explain how this mare comes about. Let me look in my notes here, just see if there's anything I'm leaving out. And wow, it does look like there's a lot of stuff I'm leaving out. Early astronomers thought these dark features of the mare were water. And you can imagine if you were looking up at the moon and saw this, that might look like water, but it's not. But they ended up...
What are you talking about, man?
No, it's not water. They ended up naming it for the Latin word for sea, which of course is mare. The plural for mare, of course, is maria, which you happen to see up here. The mare isn't water, it's just a different type of rock. The moon has no water, no air, no clouds, and no chance of hosting life for any period of time. The lighter color areas happen to be higher altitude, and they are called the lunar highlands. The highlands have many, many craters formed when small objects hit the surface. Now let's talk about craters here. Take a look at this diagram here. It goes into 3 up here and 3 down here. You can have something, an asteroid, that is relatively small, but the splattering of the rock is what really causes the bigger crater. Look at how big this crater is. It's so much bigger than the asteroid itself was. And it's kind of like if you were to take a whole bunch of flour and from a distance throw a big or throw a little BB at it. It would end up poofing up the flour a lot, and the BB would end up skidding, and you would end up with a bigger hole than the BB would fit in. And that's kind of what happens with this. Now, these asteroids are going at great speeds. So you can imagine once it hits the rock of the surface of, oh, cut it out. Once it hits the rock of the surface of the moon, it can really splatter stuff up pretty highly, and that's where you end up getting craters like that. Oh, and here's an example of a crater. Now, I'm not sure if this crater is on the moon. It might not be. I think I see a highway right here. This may be one.
I don't know. I'm pretty sure the moon has like Highway 411 on it.
Lunar highway.
Oh.
Yeah.
Oh, to put up with these guys. But
Take
anyway.
a road trip, man. Woo.
Scientists think these craters on the moon were made a long time ago. And since there is no wind and no water on the surface of the moon, they don't really erode very well. So
I lost the game. Sorry.
Whenever you have wind and water here on Earth, all those ancient craters kind of erode a lot better. Now, one thing about the Maria doesn't appear, or the Mare doesn't appear to have many craters. And there's a good reason for that. Scientists speculate, and I'll go to this screen. Scientists speculate that the craters were made a long time ago. Oh, I'm in the wrong spot. That craters were filled up with lava. For some reason, the Mare, however many years ago, was filled up with lava. And any crater that was there, you can imagine if craters were this crater here was filled up with lava and it dried, then you would, well, you would not have those craters anymore. It'd be craters with rock left in it. Now, you may remember from our rock unit that that would be an extrusive igneous rock. So the Mare is extrusive igneous rock because at some point you had lava that flooded all these low-lying areas here and ended up solidifying into rock. And yes, that was confirmed by astronauts that made it to the moon. Of course, they took rock samples of the Mare, and of course they took rock samples from the highlands, and yes, they found that that was extrusive igneous rock. And if you're wondering, the metals that were found in the minerals and the metals that were found on the moon, they're not new stuff. There's things just like we have here on Earth. So here's a look example of highland rock, and here's a look at the Mare rock. And you can see the Mare rock looks a lot like basalt. Basalt and obsidian that we studied way back when we were talking about minerals. And that's exactly what it is. I mean, you have this lava which solidified and turned in, I think it's primarily basalt, which it ends up being. And you can see that this looks like a different color than that, and that is why you have the different colors of the moon. So maybe you learned something there. Well, anyway, let's see what else I have here. Erosion on the moon can't come from wind and water, but you do get a kind of erosion on the moon. It mostly comes from crater impacts. Over time, crater impacts have broken up enough rock to form a little bit of soil there. Now this is soil that is dry and lifeless, and you can see an astronaut here is taking a sample of this soil, and you can see there's a little soil there, enough soil to make a footprint, and it does have some soil there. So that's how you can get soil from the moon. So since the moon appears to be mostly of the kind of rocks found on Earth's crust and mantle, scientists have a hypothesis as to how the moon formed. So the moon, they found, is of the same type stuff in our crust and our mantle. So take a look at this picture down here. Scientists hypothesize that there was at one point some kind of big collision that involved the Earth. Here's the Earth, and here's whatever's colliding with it. So in that collision, they wonder if big chunks of the Earth's crust and mantle were propelled outward. And after however many years, this stuff right here ended up being solidifying and collecting together and ended up forming the moon. At least that's what kind of what they think might be the case. Well, anyway, the moon does appear to be moving away from the Earth. And it's moving away from the Earth at a rate of 1.5 inches per year. If we did have some kind of collision like this, that would be a reason why the moon would be moving away from the Earth. And after many, 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 many years, it may even be out far enough to not even be in our gravitational field. What's that song you're playing? Walking on the Moon, how appropriate. Well, I hope you can muddle through all the funny stuff here, and I hope you learned a little bit about the moon.